Who here for some Spring and Kafka stuff? Just to make sure that, like, okay, cool. So, right, we found our people. Who here, like, for this guy specifically? No? No, literature fans? Metamorphosis? No? Anyone? Franz Kafka, exactly. We will try to do it not that depressing that most of the Franz Kafka books, because we're going to be talking about open source, Spring, and Apache Kafka, right?
Yes, sir.
Okay, I introduce you to. This is Gary Russell.
So I'm the project lead on the Spring for Apache Kafka project, as well as other messaging projects, Spring integration, Spring AMQP, which is our RabbitMQ abstraction. I've been working on the Kafka project for a couple of years now. We started it out.
What version was the Kafka when you started?
Well, Sobi actually started an original Spring integration Kafka project based on the 0.8 Scala client, and we started the Spring for Apache Kafka project, which is based on the Java client, since about 2 years now. Yeah.
Okay, cool. My name is Victor. I'm a developer advocate with Confluent. All things Kafka, all things Java, now all things Spring with Kafka as well, right? And today we're going to be talking on some interesting stuff, like interesting for us. I think it would be also interesting things for you, since we have a almost full room. Now, let me start by talking a little bit about the origins of these things. And these days, amount of data that is generated by mobile phones, mobile devices, everything, computers, all obviously, smart watches, other things, is increasingly growing, right? And in order to sustain this load, Kafka was basically invented, right? So it's this system that allows to absorb this huge number of messages or huge number of events into highly scalable and high throughput system. Now, also, it's good that we're accumulating this data. We can say, yeah, Victor, we can do this like for years, and we can, collect this data for 24 hours and after the process in Hadoop cluster. We also want to process data as it arrives. So it wants to do constantly computing this data, getting some results. And we also want to have, serve this data to the next consumer, right?
So can we dig in a little bit into this, into the Kafka itself and some of the architecture, the internals?
This is a good point. So with what we call streaming platform, that Apache Kafka is a streaming platform. How many of you actually know that the Kafka is not only brokers? There's a few other components that are available in the Apache Kafka website. You go into the Apache and you see there's actually 3 components that is defined by core broker. This is our distributed log. We have producers and consumers. We have connectors, and we have streaming engine, stream processing engine. And this is the part of Apache Kafka. So we will dig into some of the components, but let's talk a little bit about this.
Yes, let's see the
small abstraction. Interesting enough, when you talk to people about Kafka, it really depends who you're talking to, and when you're asking them, like, what's Apache Kafka for you? Some people say it's a new messaging system, just a similar messaging system that you used to do with JMS, Rabbit, etc. Some people can say, oh, this is just a FIFO type of thing. Some people, if you're talking to more like, distributed system papers, buffs, things, it's like a replicated transactional log with higher consistency and higher availability and durability guarantees, something like that. But essentially, what we have here is append-only file. It's the essence of Kafka. So this is why it looks like a queue, right? So you writing at the end of the file and reading of the beginning from the beginning of the file. However, there's interesting aspect about this. You can have multiple readers.
So this is analogous to these three people perhaps reading a book.
Maybe a book from Franz Kafka.
Maybe one of Franz Kafka's books. And when they stop reading for a while, they'll put a bookmark in the book so that when they come back, they can start again from where they left off.
They can put the different markers with different colors in order to understand that, oh, this is my color, this is where I stopped.
Now we know that Kafka retains information for a significant amount of time, but things can expire. And since these offsets are also maintained in Kafka, I mean, what happens if Sally doesn't come back to the book for, say, 36 hours?
It's a very good point. So in this distributed log, all messages are immutable. So you can say that author brought this book sometimes. There's some pages immutable. He already cannot change these pages. However, these pointers, the offsets, this is the way how we can navigate through. And the cool thing about Kafka is that you don't need extra storage to store these bookmarks. You store this inside the topics. Theoretically, as Gary mentioned, we can store this significant amount of time, but practically, maybe it's not that we usually do. So this is why there's a configuration that allows you some records to expire. And since we store the consumer offsets, that's how we call these things. Inside the Kafka, the consumer offsets can expire. So Sally, if she was not reading this book for some time, like more than time that's configured as a retention policy, she can come up and say, oh, looks like I need to either start from beginning or I need to start when the author of this book will start writing new pages.
Right. And I think with the 2.0 client now, they've increased that default retention for the offset.
So in the very beginning, like this kind of offsets, they were stored on the external storage. Like if you use Kafka for a while, you probably noticed that the consumer offset, they were stored in Zookeeper for a while. After some of the significant rework of the consumer code, this offset moved inside the Kafka. And starting from 1.0, I guess, the default was like a 24 hours retention policy for this offset topic. But now, default 7 days for topics and 7 days for offsets.
So it's an important issue because with those earlier clients, if you have some process that only runs Monday through Friday, and then you come back on, and you don't run it at the weekend, then with a 24-hour expiration, you'd effectively start again at the beginning on Monday. So that's why that has been increased to a more reasonable number now.
And this concept allows to do like interesting things. Allows to do event sourcing. You can read or like collect and store these events inside the Kafka, and after that, different consumers can read this different and do something different. Also, the same way how you're using bookmarks to locate the page, you can navigate through this log. Not randomly, but you can take these. For example, I remember yesterday I was reading page number 55, and in the Kafka you can take this timestamp and resolve it into actual offset, and you can read this from page 55 from because there's your famous favorite quote from your favorite author.
One thing that is not obvious from here, on your first slide, we had many devices sending messages to Kafka. If we have this one big log, how could that possibly scale with multiple writers? Because surely, if everything's in order, we can't have multiple people write into the same log at the same time.
So the question is, will it scale? How many of you guys heard this question in the conference room when you guys in architectures and so on? You will say, will it scale? Remember when I mentioned that Kafka is an interesting thing because it really depends who you're talking to, and this is why some of the concepts that I will describe right now are they very relevant to like database systems. So database systems, specifically NoSQL database systems, where you partition your data. You have data spread across multiple nodes. The same concept actually came up in Kafka world, where you can take a topic, which is your basic abstraction, but the topics actually can have multiple partitions. As you can see, I have these nodes that creates a cluster, and inside each node I have a partitions. These partitions create a topic. So my topic can have 10 partitions, and these 10 partitions will be spread across all 4 nodes. Now, my producers, they're not simple code that will just write this whatever they write. It knows, based on the key, which partition it needs to write. If you don't care, Kafka allows you to put keys to your messages. In this case, inside this particular partition, you will guaranteed have order. So like if you're running like credit card transactions, you want to have order, right? Because you want to make sure that all these operations that happened will be ordered, so you can have a credit card number as your key, and based on the key, you can figure out partition, and inside this partition, this data will be ordered. Now, if you don't want to use a key, you just want to have, as we see on the first slide, we want to just pump this data. We just want to make sure that it will sustain load, so our processing power will not be affected by this increasing amount of data. You just simply dump it there, and the producer will make sure that it will balance it equally across multiple nodes. So if you're not specifying key, it will use round robin to distribute this equally.
And of course, for resiliency, these partitions are replicated across multiple servers, correct?
Yes, and in this picture, we also want to make sure that data is not going to be lost if one of the nodes will go down or go up. So as distributed system people say, you cannot avoid failures. You need to embrace it and do something with it. You need to know how to survive this and mitigate this this problem. So you can have as many replicas as you want, but not more than nodes and so far and so on.
So how do we scale on the consumer side then?
So the most important part usually is people saying that, hey, we're more reading things than writing things. So Kafka is a system that's designed to be heavily on reads. So we also need to have ability to scale on reads. Now, Kafka is has unique this capability that allows you to scale consumer and group these consumers in so-called consumer groups. So consumer groups is it's going to be some sort of entity that allows your application to scale on writes. Let's imagine we have 10 partitions, and when we start our first instance of this application, these 10 partitions will be assigned to first instance of this application. Now, we see that this application, they cannot provide us with desired speed of reads. We can increase, we just start another consumer that will join same consumer group using same consumer group ID. And now, the broker will distribute these partitions evenly. So one will receive 5 partitions, another receive another 5 partitions. Interesting thing here. But let me actually use different analogy to explain this to you.
Sure.
There is a component that sits inside the broker that's called consumer group coordinator. And if you think about this consumer group coordinator, this is mommy bird. This is mommy bird that will take care of all these baby birds inside the nest. And the same way, consumer group coordinator will be responsible for feeding partitions to particular consumers. All right? So our consumers, as you can see, they grouped into consumer group. So consumer group is a nest. So technically, this mommy bird can fly to another tree where she has another nest and the different consumer groups there to distribute the yummy worms, aka partitions.
And so, in this case, if another egg hatched, for example, so we'd have 4 consumers, then the coordinator would rebalance the partition.
Yes. So mommy bird will stop the process of feeding and rebalance the rest of the partitions, aka yummy worms. And after that, it will see like this topic has 10 partitions. We have 4 now consumers, and we will rebalance them. So interesting thing here is that how do you think? Yeah, let me ask audience because
Sure.
let's have some conversation. How do you think? What's going to happen if mommy bird has 10 partitions, but you have 11 baby birds? What's going to happen? One of the baby birds will starve. So this same stuff will happen with your application. If you start more consumer in one consumer group, it will just idle. It will do anything because the relationship between partitions and consumers is usually one to many. So you can have only one consumer. It's minimum number of partitions that one consumer can serve. So think about this when you will plan like how many partitions you want to put in your Kafka topic. All right, so I think we can talk a little bit. Yeah, thank you for the reminder, Linus. The talk is cheap. Let's see some code. If you're interested to like follow along, there's a GitHub project that you can go and grab this link. All code is there. We'll start with something simple.
So Victor is a big movie buff, so he's been looking at creating a movie rating system that provides current ratings in real time. So
yeah, and it's a kind of like a big enterprise, and in the big enterprises, like if you want to do any sorts of calculations, you send comma-separating files, right? So all days, how we calculate the ratings for the particular movie, we're waiting for our movie provider that sends us something like this. What's your favorite movie?
Oh, Lord of the Rings. It's right there on the page there.
Yeah, so this is a Lord of the Rings movie that has this one line of this file, has information about the movie, title, country, director, all sorts of information. And in this case, it's not like typical pipe separating or like comma separating. It uses two columns in order to use pipe for distinguish some actors here. Now, I didn't like this kind of like the file thing. I just want to have this like a more dynamic, so it's like a streaming movie, right? Streaming movies, streaming. Netflix and chill, anyone? All right, so another thing. Ratings, not that exciting. Though we have some user ID information, and most importantly, we have movie ID. So if we return here, so we have this Lord of the Ring movie, and movie ID is 682. I want you guys to remember this number because you will be helping me while I will demonstrate you some demo. And let me see if I have any ratings. So it's a user ID, user ID, user ID. Yeah, so the first one is actually movie ID, user ID is the next one, as far as I can tell. No, actually I was right. So the user ID, and after that we have movie ID and the rating value. So what we will try to do, first of all, we're trying to bring this data into streaming platform so we can do some stream processing, and after that we can show you how you can update this rating in the real time. Now, in order to use this, we need to have a streaming platform. Like I need to go to like apache.org and download the Kafka distribution. I need to start Zookeeper. Kafka depends on Zookeeper. I need to start Kafka itself, so far and so on. But the good thing is that we come up with a tool that allows you to do local development much easier. So it's called Confluent CLI. That allows you to do other like cool stuff. For example, I can do something, start Kafka, right? And the cool thing about this, it knows that Kafka will require Zookeeper, so it will start Zookeeper first, and after that, we'll start bringing Kafka up. Now, next thing is that I need to load this data somehow here. Two options. First of all, I need to write my Java application in the producer, or I can use some console application. So in this particular case, if I'll go to my data directory, and I do, there's my script that I will using to populate this data. Some of the things that I will have here, I will just simply read line by line and push into the Kafka console producer. But we're in the Java conference, right? We're in the Spring world. So let's see how we can do this with Spring. So a couple things that we're not going to be doing this for movies. We will be doing for rating because our application will be populating this. But we can also watch how this data will flow into Kafka topics. And in order to do that, my screen is very... We have this thing called console consumer. And from the line 22 to line 26, this is pretty much what you need to do if you're using Spring to consume Kafka message. Pretty much it, right?
Yeah, and this is very similar. Anybody that's familiar with existing Spring messaging solutions such as JMS, RabbitMQ, we have at JMS Listener, at Rabbit Listener, and now we have at Kafka Listener for annotated POJO methods for dealing with message-driven applications.
So if we don't need to do anything, or we don't need to think about anything exciting, we just can use this message-driven POJO and just get this information as a message as is. Also, we can get the instance of consumer itself, so we can do things like manual commit of offset. So remember this story about the Sally was reading the book, and after that she needs to put a bookmark. This is how she can do it. She can do it synchronously. There's a method for committing offset synchronously. She can do it asynchronously. She can do it even automatically. Kafka, by default, uses automatic consumer offset commit based on the 5-second period. Now, so we have this listener, and let me use these tools to pipe this data in. So I will just do this.
Did you start the listener?
No, it's up. It's listener listens.
Oh, okay.
So this is now inside Kafka. This stuff inside in my Kafka, and I created some topics. Let me show you a list of topics. So some of the things that you can see here. For example, there is a consumer offset topic that I was talking about a little bit. So this is special topic, so this is why it has underscore and underscore. Usually we kind of distinguish topics that your application uses versus topics that application doesn't. Now, and the rest of the topics, so this is topics what I use. And interesting enough that I can either read from very beginning. Always, I want to read all ratings that are available there. And also, let's see how we can produce any ratings, right? We have, where's my web app? Just to restore it, just to make sure that we don't have any problems here, because it's a live demos and things might go south. Now, if we want to submit some ratings, so how it looks like. Let me show you web app. So this web app looks like very simple, and again, praising Spring simplicity and Spring Boot auto configuration things. We're writing less code, and this is essentially our code that does many things. It exposes a REST interface for ratings. We can submit this, and it also has interesting thing called Kafka template.
And the Kafka template, much like JDBC template, Rabbit template, is the producer side of the Spring for Apache Kafka project. So this is what we use to publish messages into the Kafka topic.
And if we will look in configuration real quick, so it is very easy. So in this case, I do this deliberately because we will show you a different way how you can configure your Spring application for Kafka. In this case, I do this manually. To create this Kafka template, I need to supply a producer factory that will have all configuration parameters, for example, bootstrap servers, different serialization parameters, so far, so on. Now, what was movie ID for Lord of the Rings? Great. So let's try to submit something. Sent. We have a thumbs up. So what we see here, we just got this rating. You see it here, 682. We have this listener that was sitting there and listens this stuff. So everything works. So this is like a simple idea. Multiple components can help you to do things and bring data in and data out, right? Thank you. Next. Now, the producer and consumer, or the Kafka listener and the Kafka template, is not only way how we can bring the data in. So there is a framework, there's a part of Apache Kafka called Kafka Connect that allows you to just bring data in and then data out. You can have a source connector that loads the data in and have a sync connector that can offload the data from Kafka into any source.
So
Looks familiar.
If you're using just using Kafka, or you want to use one of these connectors, you can do that. But what Spring brings to the table, in addition to the core, and we'll see the stack in a little while, the Spring integration Kafka extension enables you to build a Spring integration application around Kafka as well. So you can consume from some other entity and publish to Kafka, or vice versa, and do filtering and transformations. As for those of you that are already familiar with Spring integration, it's just we added channel adapters for regular inbound and outbound messaging, and gateways for request reply processing, both on the server side and on the client side. So similar functionality, but maybe with a bit more flexibility. But it's an alternative to using the Kafka Connect.
I would say it's the Spring integration is not only Kafka as a transport. Like many other things can be used to exchange the data. But the concept is basically foundation for any like modern ETL type of systems, where you're extracting data from some data source, you do some processing. Either you can use the things that we're talking right now, like the Kafka streams and things like that, or you can use something else. And after that, you want to offload this data, to load it somewhere. So in this case, it's kind of traditional ETL pattern. There's some available connectors, a lot of things to integrate for Kafka Connect. Now, let's focus on interesting things, right? Now, we have this data, we have this stream of data, we know how we can have a stream of ratings now, we have the loaded data of movies. What next? This is how we're writing apps. So what we need to use here is Kafka Streams, is just a Java API. We will be using Spring Boot to do a configuration for us. So we don't need to write more code. We need to write less code, right? Less code, less errors. So that's why we need to write less code. And in this case, we will be writing app. Very important point here. Code is running on JVM. Code is not running on the broker. Broker is busy enough to support high availability, to support replication, and all things related to this one. I like to think about this in a way that in database, like a relational database, you have your storage and your query engine in one process. With Kafka, you have your storage and your query engine as like two different processes. And these processes can be different. They can deal with the same data. So in this case, Kafka stays as your source of truth. But different patterns of accessing this data can be explored.
So then how do we scale in this environment?
OK, so it's a good question. Like second time we have this question, how this will scale. I want you like mentally picture this idea with baby birds and mommy birds. Remember how we did this? We doing the same with the Kafka Streams. So Kafka Streams uses Kafka clients as a foundation and the building up some of the higher level of abstraction. It allows you to focus on actual processing, but not focusing on building clusters or like do consensus between nodes, and they need to figure out who's responsible. In this case, you know who's responsible, right? This like a red bird is responsible for handling all these scalability things. if you ever, have any of you guys actually ever done like things like Spark, Flink, or something like that? Anyone? All right, we have some people here. Now, do you enjoy this? It's a good one. Okay, because sometimes you really don't know where your code is running. Yeah, you can think, okay, I just submit the job, but my process that submitting the job is still kind of running. I'm still receiving the process. If I will kill this, will it stop the job? And like, which part is the things, where to source the state, intermediate state, and so far and so on, right? This is like traditional the high scalability computing. So this is why like engineers like this gentleman over there, they love to write apps, not the clusters and infrastructures, and they want to focus on building logic. So this is what we're going to be focusing and showing today, so how you can write these apps. I'm not just like exaggerating or something like that. We actually build a bunch of our products internally based on this concept. So we know that Kafka is cool enough and provides us enough capabilities, so we don't need anything else except Kafka. So Kafka Streams, it's an integrated library. It's a part of Apache Kafka. Like if you go to the apache.org, you will find this. The Kafka Streams is a library that allows you to do stream processing. You don't need anything else. Clustering is already handled, right? To answer your question to scalability, we've already seen this with consumer group controller, consumer group coordinator. We can do stateful stream processing, and we can do stateless stream processing, right? Stateful stream processing allows us to store some intermediate results. To store intermediate results, we need to have some database. And we do have this integrated database in Kafka Streams. I would say like most popular questions that I'm getting from the people, can I do joins? Like, can I join two streams, right?
Right.
And we will answer this question today, how we can do joins and so far and so on. And you can start small. You don't necessarily need to start building cluster. You can start with one instance, one Spring Boot application that can serve all you need. You can have either things like the Spring Web to expose this API, or you can use, you definitely need to use something like as a web API to expose something to outside, but internal database will be maintained for you. And this database also will be replicated through Kafka in case of your application will go down. Now, do we have anyone like who enjoys reading the distributed systems papers, have some stack of papers printed in the restroom? Am I the only one, or am I just the only one who not afraid to say that, like, yes, I'm doing this? So some of the special theory of relativity between streams and tables. All right. Now, this is something that I borrowed from the keynote, and it actually is a cool idea that you have your organization. In your organization, you building business, and your business is based on the data flow. But what we're building is data silos. We're building like data sources, building tables. Now, how we can move this? How we can provide some velocity to this data. We saw that we just read this file line by line and kind of make it move. So can we do the same with database, right? In database world, what we can do is we can capture all events that happen in database. Like you do in certain database, it actually generates event that we can take and turn it into stream of change events. Now, and on the opposite side of things, we can take this, a stream of events, and turn it into something that has a state.
Yes.
So, but the table, this is not exactly a table that you think it is. All right? So let us, me and Gary will demonstrate you. So we have a table that we will insert some values. Like our just a simple key value, our key is a Gary, value is 1. In this table, if we will listening for changes from this table, it will generate this event that will have a key as a Gary and the value is 1. Now, I can always restore the state of this table based on the stream, because stream has full history. If you think about this, like it has a full history of our lives, but as a matter of fact, right now you're interested only in our state that we present here, right? So let's talk about this. So I'm also inserting myself in this table, which generates another event, another change event. And I always remember, we can always restore state on the other side. Basically, this is how all replication works. Shout out to Sobi. So this is, we have a change events in the middle, like these streams of events. As you can see, that if we will lose one of the sides, if we will lose a source, or if we will lose a target, we can always restore these kind of things.
But in fact, if let's say we want to reconstruct this table sometime later, we don't necessarily need this first event.
Exactly, yes, because we already have...
So we don't want to necessarily keep that forever in the Kafka topic.
Right, right. So it really depends, like in theory, yeah, we want to say, oh, we can store this forever, but in practice, like just use your, you need to figure out like how long you want to store this. Now, how it's done in Kafka, like everything is much more simpler than this. Like, okay, we're already not in the theory of the relativity of streams and tables. In Kafka, there are actually two types of topics. One topic is a regular topic where you're putting all your data in, and after that, you just appending until your retention will kick in. Now, we want to have only state. We don't need to store everything forever. So we can have a compacted topic. With compacted topic, we actually, with the stream, we will inject some of the additional metadata that will help the special process that runs inside the broker. It's called compactor. Naming is hard, so compactor does compaction, right? It will run and check what of the entries are suitable for compaction, and essentially you don't need even like send anything like any additional data. It will just always take latest and greatest value, and in this case you will store this. And it's actually a good idea. One of the customers, they might use this to rehydrate their like inventory system, because they're not interested in the like all prices for last year. They're interested in the price today when they open the store. So this is a very powerful concept. And based on this powerful concept, we use this API in the Kafka streams. All right? So let's see some code. Yeah, I remember you. We'll see some code. Now, in my application, remember when I was talking, it's good actually that I'm still here on this configuration. Let's talk about some of the configuration bits that the Spring Boot is bringing. Now, we have a different application that use Kafka streams to do processing of our ratings. And let me show you this application over here. Couple bits of this application. Remember, we started with stream of movies, raw movies that we put in the topic. In order to start the processing, from this topic, we're creating actual Java object called stream, so we can do something with it. How many of you guys on Java 6? Good. Java 7? Just one guy. Okay. Let's assume we have everyone defined on Java 8. So if we in Java 8, we are familiar with Java util streams. Anyone? Java util streams. Java util streams brings this the concept of building a data processing pipeline, like how they call it, the bulk operations on collections, something like that. So essentially, you're using like a Fluent API, and you're getting your collection, you turn it into stream, which is also kind of a similar concept in Java. We take this guy. We have this kind of influence of this API in the Kafka stream, so it allows you to build similar thing. We have this stream. Now, because we're in the Java world, we need to turn everything into objects. Like everything needs to be objects. We need to take this and parse this movie. And the cool thing about this parse, this movie, is just like some object that has certain properties, but interesting thing that in many microservices that we're dealing, we need to deal not only with Java, how we can deal with some of the stuff that non-JVM related.
Mm-hmm. So we typically have some kind of a schema to describe the data, right?
In this world, we will be using this format called Avro that actually describes our object like this. It's established a contract between our services, and I will start the schema registry because the schema registry is another component that I will be using in my application to store schemas in order to other parties of my data processing pipeline will leverage the same domain model. Schema registry, it's kind of one of the tools that we ship with our like open source platform. So, and as you can see, like I started schema registry at the check, like if Kafka is already up, Zookeeper is already up, and everything is ready to use. And I use this schema to just generate my object. And so this is why if I look on this movie, I will see a lot of things that was, code generated. And to support this, Avro has a compiler that compiles the schema in this object, and after that, your object knows how to serialize it, how to deserialize itself. So we use the schema design time, and we use Kafka will extract this schema in the runtime and save this data inside schema registry. Because Kafka doesn't care what you put inside. In many cases, like people can say, hey, can I use JSON in this case? Yeah, but the JSON has a lot of overhead in terms of what comes into actual like a payload. Mm-hmm. Now, let's return to our data processing example. Now, I parse this. In this case, it also generates a stream, and I pass this stream down to pipeline. Now, in order for me, in my application, do joins between my movies in my ratings, we need to have some common denominator. Like we need to find a way how we can join. We need to find the join key. In our case, it's easy because rating has a movie ID and movie has movie ID, right? Surprise, surprise. Now, and so this is why I have this method that does mapping. So I'm executing an operation that's called kind of rekeying. We started as remember this, in the very beginning, we have this like a buffer that, we just want to dump all these messages. Now we have a structured stream with key, data is keyed, and now we can bring some other things together. Remember when we talk about the tables, this is how we use the concept of tables here. Because we want to aggregate, because we don't really care about history of all these movies. We only want to know the current state of the movie. Because we want to join this, it's going to be like a join our master data. And our stream of ratings would be enriched by having this movie information and enriched by rating information. So in this case, we're using this movie. And we store this in the movie topic. So if you go here and try to read this from beginning, I hope it will not break. Because sometimes movies. Yeah, if I will print this, it will print some weird stuff here. Because it's right now, it doesn't print anything because I'm not running this app. I need to run this first. So let me actually run this, and after that I will explain. You want to talk a little bit about the configuration of this application? Let me open this one. Yes, Spring application.
So yeah, so one of the things I'll mention when we talk about the various components is Spring Boot has auto configuration for, even with the existing 2.0 and even 1.5, has auto configuration for Kafka. It creates a producer factory. It creates a Kafka template for you. It auto configures a listener container factory for the @Kafka listener. With Boot 2.1, which is due out next month, the Spring Kafka 2.2 a release candidate came out on Friday, we can now auto-configure the Kafka streams configuration. So we can use the application properties or application YAML to wire up your streams configuration. Spring Kafka provides a factory bean that basically gives you the streams builder that's constructed from these properties. And that's what this is an existing demo in the repo. We'll give you a link later. There's an additional project now, which is the Spring version of the original one, which has this configuration.
So, and the important thing is that we not like totally rewrite this application. We just use existing like bytes, but we sprinkle some of the Spring the goodness around in order to provide the better configuration, like easier configuration. Because like remember, like the 12-factor app, we want to our app would be externally configurable, so we can have this application YAML externally, so we can deploy our Spring Boot application after that configure. What is that? Like, why?
So one of the other features that Spring Kafka brings to the table is there's another object called Kafka admin. The Kafka clients provides an admin client object, which allows you to provision topics on the broker. And so similar to what we do with RabbitMQ, we basically detect any of these new topic beans. If we find a new topic bean in the application context, we will basically create that topic on the broker for you. And you can obviously specify how many replicas you want it copied to, and how many partitions you want. If we find that there are fewer partitions on the broker than you have in your configuration, then we'll increase the number of partitions dynamically.
So in this case, remember in my script when I was creating the topics in the script, you can do this as in your application. So when you bring an application into, I don't know, in the cloud, so you're running your Kafka cluster on PKS, you're running your Spring Boot application with Kafka streams in the Pivotal Web Services, and you don't know, like, you don't need to go and tell admins, like, go provision my topics. Your application can provision and brings everything together, and using these capabilities, like, your application will be self-sufficient and will not fail, because sometimes, like, when you're using consumer and producers, the consumer and producer will try to listen some topics, and after that say, hey, looks like there's no topic, but I will create. In production environments, usually auto creation of topic is disabled. So using admin API and using this from your app,
plus with using broker auto provisioning, you're pretty much fixed on the partitions, right? The number of partitions you get on broker auto configured is a broker property.
Exactly. So when you're not providing the number of partitions, number of replicas, and so far and so on, it will use default from the broker configuration, and you don't really know if you're running on the shared environment.
So this gives you more control, basically.
Yep. And to return to our application, so let me show once again a config. To wire things together, Stream Builder will be instantiated, and only thing what I need to do is put together two things. One string has I will turn stream get ratings overage table. So essentially, what it does, it reads a stream of ratings. It will calculate overage rating and saves it in a specific topic. Now, this is kind of cool things is hidden here that I already mentioned, like there's like an embedded database. So every time you're doing something like this, like materialized, for example, you're actually creating local store where you collecting these aggregates. So in case of failure, your application will restart and will restore state from this. And interesting thing for debug only, so as you can see here, I was trying to debug this like before session. Interesting thing here, there's like method pick allows you just to see like what is actually going through the stream. So it's a very nice way to debug this, similar how you can do this with some other APIs. Now, and interesting thing here, over here, I'm actually doing table-to-table join because I have movies and I have my overage ratings, and based on movie ID, I'm creating a table that will contain rated movies. So First thing first, let me start and start listening a topic called rated movies. Now, I will do Spring demo, and I will run this one. So this will start application. This application will continuously run and continuously listens for some data. So we see here there's some data went through, some of the ratings data, and we have some of the results of rated movie. So let's see if we can do, if we can improve rating of the Lord of the Rings. So we can send multiple requests with the 10. So the highest rating. So as you can see here, rating was improved. So we have this listener that listens this topic, and the Kafka console consumer, it's actually really don't care if it's compacted topic or it's a regular topic. It will listen to this topic, and you can display this information. Also, in my debug information, I see that for a particular rating, I recalculated this rating over here.
So now instead of the old days where we'd recalculate the ratings once a night.
Yeah, now we can do it as they arrive. So, and the cool thing is that tomorrow we decide, okay, maybe average is not very good algorithm for calculating ratings because you can send multiple bots that can start sending 10 stars. You need to figure out different algorithm. You already have this data in Kafka. You can always replay and you can remove all these anomalies. For example, you want to ignore highest rating and lowest rating. And with stateful stream processing, you can collect what was the maximum rating value. In this case, you can store it somewhere, and minimum, because in the different movies for different movies, this rating might be different. What's the minimum and maximum? So this way, it also will be reflected to the result. My favorite movie is Pulp Fiction, so I will go ahead and update the rating of Pulp Fiction multiple times. Now I improved my rating of Pulp Fiction a little bit. But not much, because its algorithm is not super smart or not very sophisticated, right? And when I will continue to run this, it will continue to work. I can scale this. I will start another instance of this application, and after that I can increase parallelism of the processing. Now.
So this talk was walking up the Spring stack for Apache Kafka. So we've given you an overview of what Kafka is and some indication of what Spring brings to the table. So I just want to summarize that now in terms of what Spring provides in terms of course, everything Spring is based on the Spring framework. Spring for Apache Kafka is, as I said, that was started when the 0.9 client came out and has been enhanced. Now, there was a lot of volatility with the Java client in the early days. So, unusually for Spring, we ended up having to produce quite a number of versions. We're currently the next version to come out is 2.2. So 1.0 was only 2 years ago. So, and then the 0.10 client came out, so we needed a 1.1 and then 1. Anyway, so that's just history. There was a fair amount of volatility in the client, so we ended up with a fairly rapid release cycle. That's now stabilized greatly, and the 2.2 version, which say the release candidate was released on Friday, is based on the latest and greatest 2.0 client. And I'll have another slide in a minute just to talk about.
An interesting aspect here that Spring and the Spring integration actually brought some of the cool concept even before they were available in actual Java Kafka clients. For example, headers. Right. Headers were available for a while,
Yeah, we did some tricks with, especially with Spring Cloud Stream, to embed headers within the message
Community
body.
were asking about these headers for a while,
Yes.
and for people who use Spring for for that matter, it was not a problem.
So the other nice thing that they've done with the clients, certainly since the 0.10, maybe 0.2 client, is they're all backwards compatible. So that even if you're a Kafka broker, you can't upgrade that. We still recommend using the latest and greatest version of Spring, the Spring project. Back to for those of you is anybody still using Boot 1.5?
Anyone? 1.5?
Hasn't moved up to 2. So Boot has some fairly strict versioning, dependency versioning, and so Boot is still bringing in the 1.1 version of Spring Kafka. We recommend, the project page explains why, we recommend moving up to at least the 1.3, well 1.3.7 is the latest 1.x version. 1.3 introduced a much simpler threading model because there was there's a thing called Kafka improvement process.
Kafka improvement proposal.
So KIP62, just Google KIP62, made the use of the client much simpler in that it does heartbeats in the background now. In the old days, we had to play a lot of games to prevent Kafka from rebalancing if we detected that the consumer was slow. So definitely, if you're on Boot 1.5 and you're using Kafka, please upgrade to 1.3.7. On top of Spring for Apache Kafka is an extension to the Spring integration project. The reason it's an extension and not part of the core project is for the same reason that I just described, the volatility. Spring integration itself has a fairly long release cadence, maybe 9 to 12 months. Whereas we were releasing new versions of Kafka every few months in the early days. I foresee that it will eventually become part of the core project. Not sure when, but in any case, that's why it's an extension. So Spring integration, for those of you who are familiar with, anybody using Spring integration elsewhere? So it brings in the usual suspects, the inbound and outbound channel adapters for one-way integration and gateways for request reply, both on the server side and the client side. Then Spring Cloud Stream is another layer. It's an opinionated Spring integration application, really, and it does more opinionated configuration. So it again takes away a lot of the work from the user. And of course, I'm going to add in Kafka Streams there, which Victor has been talking about. Spring integration isn't involved in Kafka Streams, but the Spring for Apache Kafka project does provide some support for streams, in particular a factory beam for creating the streams builder and configuration, which Boot now in Boot 2.1 will auto-configure, as I mentioned, will auto-configure the streams factory beam.
And the cool thing about all these things is that, like Spring Cloud Streams, it's kind of abstract from the transport.
Yes.
So essentially, configuration-wise, you can change after.
Indeed, yeah. You can. Yeah, I mean,
or using conditional annotations to disable or
exactly.
enable.
An existing
like
application you can choose whether you want to use Rabbit or Kinesis or whatever as your transport. But Kafka is one of the supported, and we do have two binders in the Spring Cloud Stream. One that's message-based that uses Spring integration channel adapters, and one that's Kafka Streams-based. While it's not strictly part of Spring, I've added Reactor Kafka here. There is the project Reactor.
Anyone is using like a Reactor Kafka? One gentleman, right?
Okay, so Project Reactor is obviously the reactive solution from Pivotal, and Reactor Kafka is a project within Project Reactor. And then, of course, your application sits on top. So that's the full stack in terms of Spring and Spring's relationship with Kafka. And I don't think I really have much more to say, except, as I said, try and keep up on the latest versions whenever possible. On that front, so what's actually new in 2.2? One thing that most of these enhancements, by the way, came from the community. You may or may not be aware, but we monitor Stack Overflow very actively, and quite a number of suggested features come via that mechanism or through GitHub issues. One of this first bullet here is the @Kafka listener annotation that Victor showed. Behind that, we have a thing called a listener container factory, and the listener container factory, which is created by boot, is used to create a listener container for each of those annotations. However, there are other cases where people say, well, I want to use that. I don't want to use the @Kafka listener. I want to use a Spring integration channel adapter, but I want to use boot's auto-configured thing. So one of the features we did in 2.2 is you can now use that container factory that's created by boot to create any container. For example, like I said, it's the way you want to inject it in there. A couple of minor changes to the Kafka listener annotation itself. One of the issues, if you wanted to have different concurrency on different listeners, is you'd have to have a different container factory for each listener. So now you can override the auto startup and concurrency properties at the annotation level, and of course they can be property based or even spell expressions as well. But that was another user requested feature. Something we added in 2.0 is a seek to current error handler, and we also added when using Kafka transactions this after rollback processor. These are used to seek a topic after an exception so that the same message will be redelivered. The difference between the two is the error handler would be invoked within the transaction so that the error handler has the opportunity to prevent the transaction from rolling back, whereas the after rollback processor is called after the transaction completes, so we can do the seek there. So in 2.2, we added a notion of recovery to those elements so that after some number of attempts to deliver it, in a real world, if something's got a fatal flaw in it, some message has a fatal flaw in it, we need to keep trying it. Like, doctor, don't do it. It hurts when I do this. Well, don't do it, right? Yeah. So we have this. You can just add a recoverer. You can say you can do whatever you want. Like after, and the default is 10. So after 10 attempts at delivering it, we call the recoverer and say, what do you want to do with this? And we also have provided a dead letter publishing recoverer. So it will actually automatically publish this poison message, much like you've probably seen this terminology in JMS. Publish this message that continually fails off into another topic, so you can maybe go look at the data later and figure out what's
it's actually
wrong with it.
Very important from perspective is that when I was talking about Kafka brokers, you're not running any logic in the Kafka brokers. Kafka brokers will, make sure that you're not losing data and stuff. And this like concept where you have your, processing or query engine outside of your Kafka broker. This is actually a very good kind of abstraction that allows you to kind of don't think much about this and writing your own code. Usually the people they just come up with some custom code, but in this case, the frameworks will get you covered.
Right. So a similar problem is in deserialization. So Kafka itself can be configured to deserialize the byte, much like the Avro that Victor was using. Or let's say you have a JSON. The framework provides a JSON serializer and deserializer. But let's say you've got badly formed JSON, right? So it gets to the deserializer. The deserializer throws an exception because it can't deliver it, and then Kafka's just going to keep. There's basically no way to deal with it. And in the old days, or the way you would have to do that would maybe shut down your application, use the Kafka topics console client to move the offset, and just basically get past this bad record. So what we've done in 2.2 is we now have this error handling deserializer, which basically is a wrapper around your deserializer. So what it does is if the deserializer throws an exception, we just go ahead and give to Spring an exception that basically tells the listener container, this is a bad message that failed deserialization. That the exception contains the original byte array that we tried to deserialize. And the container is smart enough to, when it sees that the payload of the record is this deserialization exception, it then just hands it directly to the error handler rather than giving it to your broker.
But this is only for Kafka clients, like a consumer message listener, the Kafka listener,
yes.
Pojo.
Yes. Well, I mean, but you could even if you're using the consumer client, you could use this same one. It's just that you would have to add your own logic.
In the Kafka streams, there's similar concept because Kafka streams is Java API,
yes,
and
exactly the same.
It has a similar like a handler in order to, like, if you're failing something in the processing, you can just skip it.
And then the final bullet there is that the Spring Kafka project does provide an embedded broker it's mainly used for unit tests or integration tests, and we've now upgraded it so it'll actually work with JUnit 5. Last bullet there, as I said, the release candidate went out Friday. I think boot's due to ship towards the end of the month, so we'll probably be a few days before that for our actual release. Any last minute late breaking changes that you want us to consider getting in, then you have a very short window right now.
I guess we even our demo, we're still using some of the like M1, M3 or
right,
FC1.
Yes.
So
yes,
it's kind of like it's cool to live on the on the open source. Open source, right? It's really cool stuff. Like small announcement, like if you're in the Kafka Jazz and you happen to be in San Francisco, we do have an event that we're running called Kafka Summit, and I'm inviting every one of you to join. There's like a special promo code that gives you the 20% of the tickets. So I hope it's like all like a premium event of Kafka stuff, like people from Apple, Netflix will be there. So it's cool stuff. Important, do not leave. Important thing that in your apps, you will have a rating thing. Rate this session like a thumbs up or like a 10, because this session was about ratings, like highest ratings, right? Do not forget that you can get this movie streaming demo and all sorts of Kafka Spring integration demo from the second link. Like, we didn't cover many things. We didn't cover like a reply response queue, so you can build a synchronous communication, synchronous microservice communication through the Kafka using this reply topic. We didn't cover many things related to Spring Cloud streams and how you can build apps. This also, do not forget, like look at tips and tricks from Josh Long. He also covered Spring integration for Rabbit and for Kafka, for many other things. So stay tuned. If you have particular questions to Gary, you can find his Twitter. If he was like cautious enough, you saw this Twitter was over there on the slides. You can always tweet him. You can always tweet me. Hashtag Spring1. We will take the photo. You can tweet us right now if you want. And
well, the other thing I prefer if you have some code that's not working the way you expect, we prefer like Stack Overflow with the Spring-AMQ Spring-Kafka tag. That second link there. There are a bunch of apps. There's just some basic Spring Kafka. And then there's a Spring integration version and then a Spring Cloud Stream version. They all do pretty much the same thing, but they sort of walk you up the stack in terms of...
I think we have 2 minutes for 2 questions. Yes, please. How you would dealing with scaling up partitions when you need to deal with ordering? It's very simple. You're either using some tools that was designed for this. For example, Auto Data Balancer can rebalance this and replay, or you can use like Replicator to replay. Or there's no other ways, unfortunately, right now. So you either need to replay, or you need to give up on ordering, or migrate from topic with less number of partitions to the topic with larger number of partitions. You can do this with Kafka Streams. There's a method called peek that just simply,
and if you have affinity requirements, like you always want partition 0 to go to a particular instance and always want partition 1 to go somewhere else, then you can configure the consumer to explain, instead of using this auto rebalance mechanism, which
you can stick to particular
doesn't help with scaling, but you can pin particular partitions by doing explicit assignment yourself.
One more question. Yes, please.
Compare this case-free implementation in Spring integration and Kafka case streams. Can you compare the applications written in these two?
Can you compare Spring implementation of
Implementation of case streams in Spring integration?
Case streams, Spring integration is not involved with case streams. So you can do similar things. You can transform objects, you can filter them, you can do the same thing, or you could use a case. Is that what you meant?
just give me a second. Once again, in this picture, we show that there's nothing to compare. The frameworks complement each other. So you can still have your Kafka Streams code and wrap into and bring the Spring Boot and use all these goodies of auto configuration without thinking much of the, all this, how we call it, like a prelude for the things, right? So it's nothing, they're not competing. There's nothing to compete. Yeah. Kafka Streams is the Java framework, allows you to write a string processing application. In Confluent, we developed a thing called KSQL, which is a system that allows you to write SQL queries on any languages, so just a REST API to perform your stream processing applications. Yep. Thanks for your time. If you have any questions, we will be hanging out like today, tomorrow, somewhere on Expo Hall. Don't hesitate to stop by. We'll love to talk about this stuff. Again, hit us up on Twitter. Thank you so much for your time. Do not forget to give it the highest rating for this talk. Thank you so much.